put the 99 in for temperature because I know that at time equals 0, this formula is supposed to give me 99. So I just set the formula equal to 99 and I solve for the C. Good?
What was R?
R I don't need to know because when I put T in there as 0, R times 0 is 0. And e to the 0 is 1. So they just, everything goes away in that exponent, which is nice. Got it?
What if T was like 3? What would R be?
We're going to get to that, unfortunately. I left the good stuff for last. So far, so good, right? The number here, easy. It's whatever temperature you have externally. So with 70, it's thermal equilibrium, where it's supposed to land at. That number is always going to be room temperature or the outside temperature, wherever the dead body was. This number is easy too. You just plug in T equals 0, it makes that term be 1, and I just set C plus 70 equal to whatever the temperature was at time 0. That's easy equation, right? The last one's hard. Our good times are over. Okay, everybody got this?
Does it stop there or no?
No, we got one more letter, right? Here's where we're at now. I'm trying to get a formula, just one formula to crank out for me all the temperatures. I got C now, it's 29. What am I after here? I want to just plug in time and have it tell me what temperature the body should be. So it wasn't supposed to be 1.5 every hour, but this formula is supposed to give me the right answer. But the problem is I got an R here. So I can't just plug a time in there because I got to get rid of that R first. How do I get rid of the R? Well, I got to use the second data point. So I'm going to use this one. At time equals 3 hours, I got the answer. So I plugged in time equals 3, sorry, not 29. I plug in 3 for time. Well, if I wanted to ask you guys, we have a meeting Wednesday about it, but if you had to, knowing what you know now about PreCalc and what you needed, what would you go back and say needed to be fixed in the Math 100 so that you're ready? Right? While you're taking Math 100, people don't want to do it, but when you're in PreCalc, just imagine that you had, I don't know, a situation where someone says, this is WebAssign, this is my notes, see you later. Think about how that, what you would have needed to fill that, because everybody teaches different, right? You need a way to succeed in no matter what PreCalc class you're in. Share that with me. Think about it. It's actually pretty important. Okay, I'm going to solve this step by step. I'm drawing it out.
Why do you right now use 3 R?
Oh, I rotate it around because I'm used to seeing the letter after the number.
Should we do that? Should we do that?
Yeah, it's probably easier to look at it. It's weird to see the R first and the -3 second, right? Don't you usually have 3x, not x3? That's all. That's a habit. Okay, step 1. So unlike the book problems, this has a purpose. I want a formula that works. I had a constant rule, is easy, but it didn't work. So I want a formula that works. I'm after that formula. That's all I'm after. So to get that formula, I just want to plug in time and get the temperature. I want that relationship. The problem is I have this R in there. I need to get rid of the R. So I want it to go away. So here's what you do. Step 1 is you isolate this term by bringing the 70 over to that side. Can I put E stuff? Anything attached to the E stays on the left. Anything not attached to the E goes on the right. So I'm going to take that 70 over to that side. So this is where I'm at now. Good? Second step, you really need to get the E by itself, so that 29 has got to go away. How do I get it over to the other side? Divide. Whatever number's in front of the E stuff, it just goes on the other side. So I get E to the minus 3R equals 26.5 divided by 29. And I don't have a calculator, and you have these nice TIs in front of you, so give me that number.
0.91379.
Okay, let's do 0.91, right? Be careful if you're in Kasner's chemistry class. 0.91? Significant digits.
I think so.
Careful, careful.
I hate that class.
It's really important if you're taking PCAM though. All right, so 0.91. Now I want to get this 3R alone. So here's the new step that you haven't seen before. You've got to somehow, you know, like the angles, we had to back calculate the angles by hitting both sides with an inverse. You have to use the inverse of the E. And the inverse of the E is the button on your calculator that's called ln. I had an ex-boyfriend that called it in. And I thought, it's ln. Maybe we should say goodbye. Not in, ln. So everybody has up to here? You can erase that? That's the problem with the small board. So ln's a button on your calculator. You can actually calculate ln of 0.91. This is a real problem. It's a real applied problem, so we don't worry about getting exact answers from WebAssign. We're actually trying to solve something here for real. So natural log of 0.91, what do you get? I need several of you to type it because somebody might type it in wrong.
Negative 0.09.
Negative 0.09? Is that what everybody got? Negative 0.09? So you got ln, the ln button, and then put 91 in it, 0.91 in it. Zero 1 or 09?
09.
And these two, this is how you back calculate the stuff inside. It's just like the angle business. We call them inverses of each other. When I used to say inverses and things like that when I did medical talks, back calculation. That's what you're trying to do. You're trying to get after this piece right here. So you're back calculating and going backwards and saying, where could it have come from? ln does that back calculation. Just like in the angle problem, sine to the inverse gives you that back calculation for the angle. It's the same idea. So now I can do this. This is like solve for R. Easy. It's easier than that stat class you were talking about. All right, give me that nice number on the calculator. 0.02? 03?
0.3.
Okay. Like that?
No.
Point 0.03.
Okay, so now I got my formula. T of T, the temperature every hour after death is given by 29 e to the minus 0.03 time plus 70 degrees or whatever room temperature. Well, that makes a difference, right? I used it to find the other number, so I'm using 70 degrees. If it was 75, all these other numbers would change. And you can program that to be automatic. Odie?
I only got 1 0.
Fuzzy?
I only got 1 0.
Point. Oh, I put a 0 in front.
No, I'm talking about like the other side.
This you did that 0.3.
Yeah, for these calculators, we got 0.3.
Did you get 0.3 or 0.03?
0.03 I got.
0.03? Okay, so there's no 0 there. Right, thanks. That's why we do it all in class. No?
0.03.
Yeah, this is 0.03.
Yes.
You can't see the point from back there probably.
Oh,
I put a 0 in front of the point to indicate that it's where the decimal is.
you have to put that 0 there or no?
I've started doing that since I worked in medical science, not before, because before I know the difference, but I make everything very, very clear. And still, despite all the effort I put into it, still, it's hard. It's hard to explain this in a 20-second elevator speech. That's what you want. People are busy. They don't have time to listen to hours and hours of math.
I have a question. Like for the formula, wouldn't it be 0.03t instead of negative?
No, it'll be negative. Right.
Even though
Because it's R I solved for. Right, it's minus right. It has to be negative because if it's positive, the curve goes the other way.
Okay.
So now we have a formula. Keep this formula because I'm not going to remember it. And on Wednesday's class, I'm going to give you some homework problems related to this formula for next Wednesday's quiz. So you can actually do some back calculations of time of death.
Professor, you know